This is a part 3 recording of a polymorphism subseries where I will explain dynamic binding, which is a key concept that enables dynamic polymorphism that I discussed in the previous recording. Let me use this code to explain the dynamic binding. The code I have, it contains the base class animal, which has the function member function called sound displaying this text. It has a destructor, virtual destructor. Let me remove the virtual keyboard at this moment, which has a destructor. It doesn't have data members. We have a derived class dog, which is derived from animal class, which also has its own implementation of sound function, which displays this text. It has a destructor, and we have another class cat derived from animal, which has a member function sound displaying this text with a destructor. And we have one public function print, which receives a pointer to animal, and it calls the sound function through that pointer. And in the main function I didn't have anything. So to discuss dynamic binding, I should start talk a little bit about static binding. Let me start something called static binding, or it is also called as early binding, or sometimes it may also be called as compile time binding. So for example, if I have a function which displays this text, and I have a statement calling this function. In this case, when the compiler compiles this code, compile has to determine when this expression or this line or this statement is executed, and what should be done. The thing that should be done is a function should be called. That means compiler should connect which function to be called, or this function all the statement logic of this function is stored in one memory space, and it has to link this function invocation with the place in the memory where this function or its instructions are stored. In other words, compilers binds this function invocation with function definition. And for the compiler it is very easy, because we have only one function with this signature. So compiler will when it does compilation, it will bind this function invocation with this function definition. So when it is done during compilation, before the program starts getting executed, then that sort of binding is called static binding, or early binding, or compile time binding. Similarly, I have this hierarchy of a class, and if I have a pointer, animal pointer, and this pointer is pointing to animal class, and I call the member function of this class, this sound member function, through that pointer, and again I would delete, and again aptr new doc, and then I use the same pointer to call this function, then delete again, cat call, and finally we release the memory. So in this case, what happens is, if we have this kind of structure, then I will execute and we'll see what function will be called. But what compiler does is it determines the type. Animal is the something called static type of this pointer. So it will go ahead and look for the static type, and it will actually bind this function invocation with the function member function of static type. That means sound function of animal class. In this case also the same thing happens. It will bind to the sound function of animal, because static type is always for this pointer is animal. So it will also bind with the sound function of animal class, and this function call will also be binded with sound function of animal class. So we will see that in execution. Let me go ahead and execute, and if this function, this text is displayed in all cases, then we can be sure that it was binded with this function, not with this function. If it was binded with this function, it would display this text or this text, right? So let us go ahead and execute this code and see the output. Compilation and linking, and execution. So the text that is displayed is the same text in three cases. That means it was binded to the base class version of the function. That means the sound function belonging to the static type. So this sort of binding is called static binding, because compiler can determine when it is compiling, it knows what is the sound function of static type, and it can immediately bind it, right? That this function invocation, which function this invocation should call, is actually done during the compile time. It is determined during compile time, so it is static binding. But if I have let's say a function, like for example this print function, and I call this function here and pass this pointer to it. In this case, what happens is this function, when compiler does process this print function, this print function has the invocation of the sound function. So this invocation of print function is actually static. Compiler knows which function to call for this print. So at compile time, this print function is binded to this print function. That is called again static binding. Let me in all cases at this point it is static binding, right? Because we don't have a dynamic polymorphism implemented. If you have watched my previous videos, the thing that actually makes dynamic polymorphism possible is the virtual function. So if you put keyword virtual, and also it's recommended you put virtual function here if you want to avoid warning information. So if this function is virtual, in this case compiler doesn't know which function to bind at this point, right? So it will postpone, it will defer binding process to runtime. So during runtime, whatever object when the program control comes in this point, and whatever actually dynamic object this pointer is pointing to, based on that it will look into something called virtual table, and that virtual table will have the information about the function location based on the name of the class. So based on the type of the object it is carrying, it will look into the virtual table and it will bind the this invocation with the corresponding the sound function. Either it is going to be binded with this function or this function or this function, based on which is the dynamic type or dynamic object that pointer is pointing to. That process is called dynamic binding. So at this point we have a virtual keyword. So if I go ahead and compile the same code, I'll see different outcome. So now you can see in the first case, this was the, I mean, um, in all cases it was a dynamic binding, because the binding was postponed till the runtime, and at the runtime, based on which dynamic object it is actually pointing to, then corresponding function, it is invocation is binded to that corresponding function, and that function is invoked. So we can see the different text: animal makes sound, dog growls, and cat mews. So this is all I have to talk on this topic. Thank you for watching this video.